Okay, so we're on page 28. Suppose you are interested in learning whether a baby's gender is associated with mother's weight gain during pregnancy. Actually, it should say baby's sex, right? Babies don't have gender. They're not thinking about how they think of themselves, right? In particular, you are interested in comparing the proportion of mothers who gained more than 30 pounds during pregnancy for male and female babies born in the U.S. in 1997. A random sample of 200, that's your grand total here, 200 gender and mother's weight gain measurements were taken and were tabulated as follows. So let me start with my observed matrix here. Less than or equal to 30, greater than 30, total. Male, female, and total. 68, 35, 103, 52, 45, 97, and total 120, 80, and 200. Use this data to test the null hypothesis that the proportion of mothers who gained more than 30 pounds during pregnancy was the same for male as well as for female babies. I'm on page 28. Okay, so this is a special example because it shows you how you can screw up. I'll point it out to you. What is P1 hat? Pardon me? What is P1 hat? P1 hat is the proportion in the first sample, right? Can you find me P1 hat? I'm doing normal theory method. Is what greater than 30? Is
that P1 hat?
P1 hat is equal to x1 over n1, right? So, which is x1 and which is n1?
Would x1 be like 3,580?
X1 is 35 and x2 is what? I mean n1 is what?
80, because like can't do less than 30 because it's in the central hemisphere.
You have to be really careful. Look what it's asking. It's saying use this data to test the null hypothesis that the proportion of mothers who gained more than 30 pounds, so I'm interested in more than 30 pounds, during pregnancy was the same for male as well as female babies. So they're saying this is your first sample, male babies. This is your second sample, female babies. And you're interested in the proportion of mothers who gain too much weight. So this is your x1. x1, n1. It's saying out of all the male babies, how many of the mothers gain too much weight? x1 over n1, x2 over n2, x1 plus x2 over n1 plus n2. Do you see? So unless you read the question properly, you're going to get the P1 hat wrong, you're going to get the Q1 hat wrong, and then your P tilde will be wrong. It'll be all wrong. So you want to read it carefully. It didn't say what percent chubby mothers had male babies and what percent of not mothers who didn't gain too much weight have male babies. In that case, it would be 68 over 120 and 35 over 80, but that's not what it's asking. It's saying, look at male babies and female babies, and we want to know if the percent of mothers who gain too much weight is different in those two samples. Follow me? Okay, so let's do the normal theory method. Let's do it by hand. Let's do it on the calculator. Okay, so how does this method go? Z naught equals P1 hat minus P2 hat minus P1 minus P2 over radical P tilde Q tilde rad 1 over N1 plus 1 over N2. The reason for my doing this by hand today is because if your P1 minus P2 is something other than 0, you will have to do this by hand. The calculator has no place for you to put in P1 minus P2 equals 0.1 or something like that. Follow me? So I'm not just doing this to waste time. I'm doing this because if this is something different than 0, you have no choice but to go this route. Okay, so P1 hat, we said, is X1 over N1, which is 35 over 103, minus P2 hat, 45 over 97, minus 0 in this case, because I'm testing to see P1 equals P2 versus HA P1 not equal to P2. And then I'm going to bring the P2 to the left side. P1 minus P2 equals 0, and this is P1 minus P2 not equal to 0. So my test statistic continued is divided by radical P tilde is X1 plus X2 over N1 plus N2, 80 over 200. Q tilde is 120 over 200. Because Q tilde is 1 minus P tilde. Rad 1 over N1 plus 1 over N2. Let's get this test statistic. Let me grab my calculator. So on the top I have 35 divided by 103 minus 45 divided by 97 minus 0.124111705 divided by 80 divided by 200 times 120 divided by 200. Take the square root of that. 0.48989799486. 1 divided by 103 plus 1 divided by 97 and the square root of that. 0.1414850388 times 0.48989799486 minus 0.124111705 divided by answer. Did you get minus 1.79? Equals Z naught. Next, I go to my Z. It's a two-sided test because of this. So label it Z. Split your alpha. Let's say that alpha is 0.05. So 0.025 and 0.025. Then we go to our T table and look up 5 column and the last row. So this would be 1.96 and minus 1.96. And your test statistic is negative 1.79, so that falls here. That's Z naught. So conclusion, do not reject H naught. There is insufficient evidence that the proportion of mothers who have gained more than 30 pounds, actually it's just greater than 30 pounds, is different for male versus female babies. The test is not significant. Test is not significant at alpha equals 0.05. Can we find the confidence interval for this one? It's two-sided, so let's do it. We would need the 1 minus alpha CI for P1 minus P2. So that would be the 95% confidence interval for P1 minus P2, which is given by P1 hat minus P2 hat plus or minus Z alpha over 2 radical. You have to be careful because this one doesn't have the same denominator as up here. This one has a different denominator, okay? This one would be P1 Q1 over N1 plus P2 Q2 over N2. Here the denominator assumes that the null hypothesis is true and that P1 equals P2 and that there's a common P tilde. This one does not assume that. So because I don't know P1 and Q1, I'm going to use the sample proportions. P1 hat, Q1 hat, P2 hat, Q2 hat. So plugging in, I have 35 over 103 minus 45 over 97 plus or minus 1.96 and then rad 35 over 103 Q1 hat is 68 over 103 plus P2 hat 45 over 97 Q2 hat 52 over 97 this one is divided by N1, which is 103, and this one is divided by 97. And the whole thing is under the square root. And then I clean this up. Now, this confidence interval is independent of what P1 minus P2 is. So, in every instance, you can do this one on your calculator. So for that, you would go stat, test, to proportion Z interval. And for this one, it was stat, test, to proportion Z test. Follow me? Okay, so let me get this by hand, let me compare it with the calculator, and then let's draw a conclusion based on the confidence interval. So let me do this part. 35 divided by 103